Again, welcome to Java Unit 1, Part 2 lectures. Again, this is Java Unit 1, Part 2 lectures. It's the continuation of the previous lectures. Again, introduction to Java programming. Our main objective today is again, go through the Java programming language concept and also the process of developing a program and the main idea of what is an object-oriented programming. So what is Java? Here we say a Java programming language was created by Sun Microsystems Incorporated in 1995. But again, it was sold to Oracle. So today, Oracle owns Java. And the programming language specifies words, symbols that can be used to write a program. So we have to follow some rules or protocols in language. For example, in English language, I know if I write a sentences and I want to end a sentence, I will end it with a period. I can write a sentence and I haven't finished yet, but I want to take a few, maybe a second break, I will use a comma. So with programming language, the same concept. In Java, when I write a sentence or an expression, I will end it with a semicolon if I'm finished. So a programming language, again, have its own, we use the term syntax, has its own grammatical rules. And that's the term we use, syntax rules. So a set of rules that will dictate how the words and also the symbols can be put together to form a valid programming statement. So a Java programming structure should have these three listed items. First, a program is made of one or more classes. So in Java programming language, even when you are writing a basic program like welcome to, or just one statement, hello world, or welcome to CIS 55 class, I still have to write just only one statement, but I still need to have the main class. I have to write it in a main class. So a Java program should have at least one or more classes. I have the main class. The main class name of the Java program is the name of the Java file, will be the name of the file. I can also create my own classes. From the class, I'll create an object, etc. And we may discuss this later on. So a class should contain one or more methods. When I write a very simple program to print hello world, at least I'll use the main method. Main method is where the execution will take place at. So every Java application must have a main method. So a program is made of one or more classes, and a class should contain at least one or more methods. Then the methods normally contains the program statements. So here I'm writing a program to print hello world. So my statement will be the hello world inside the main method. And the main method have to be inside the main class. So this thing will be explored in detail throughout the course. What is a class, method, statement, expressions, etc. So a Java application always contains a method called a main, as we said earlier. Java, here we are doing Java application. We have Java applet, we don't need a main method. So let's see the structure of a Java program by going through a program called linking.java. Excuse me. So in Java, the file extension name is always .java. So you have a Java, the name of the Java file is linking. The extension is .java. So this means my main class name will be linking. Let's see the program. So this is the program. Here we are assuming this is the first time we are learning Java. So I'll start from the top. Here we see a double / with asterisks. These are called the comments. We may discuss this a little bit detail. So the comments can include who wrote the program, the purpose of the program, what the program is doing, the date the program is written, etc. So that all can be comment. Comment will be, again, ignored by a compiler. So here, for example, we have a program now. This program, we call it the source file. Almost everything is in English. Computer doesn't understand this language. This is I would say this is an English language. We have a class, main, system. These are all English words. So this means we need a special program that will translate this program into a machine language. And we use what we call the Java compiler, which again can compile it. We compile this program, then from there we execute it. And we may discuss this later on. Just for now, I want us to understand the concept of what is a class, what is a method, and what is a statement. So here we have a program. As we said earlier, a Java program should have at least one class, and that's the main class. So we use the keyword public class, and the name of the class is linking. This is why the name of this file will be linking.java, because this is the main class, is linking. Then we have a comment what the program is going to do. Then we have our main method. So here we say public static void main string args stand for argument. We may again discuss this in detail. I will explain it in detail. So this is our main class. We have it called the linking. We open a parenthesis. That will be the block, the starting block of the main class. And that's the end. The last parenthesis asterisk curly brace is our last. So I open it. Now, when I start with the main method also, I open the block. So I open a new curly brace. Then I have my statement. So my statement here, system.out.println, we use this to print the argument here, which is a code by Abraham Lincoln, on my monitor on the screen. Then whatever you are, be a good one, also will be printed on the screen. So in Java, when we want to print something on our screen, let's say the monitor, we use the system class, system.out, then the print or println method. Println means when I print the items here finish, I'll move to the new line. So ln stands for new line. If I write print, when I print a code by Abraham Lincoln, the cursor will still be in the same line. Then whatever you are, be a good one. Everything will be on one line. But println means when I print the item here, the cursor will move to the next line. Then I'll print, so I may have two lines here. So for now, again, I don't want us to understand the details here, but why we are going through this program is what is a Java program. A Java program should have at least one class or more. One class is the main class. Then it should have at least one method or more. At least the main method, always we should have it when we are writing Java application. Here we are doing Java application. The main method is where the execution takes place. And now this is our statement here, system.out.println. I want to print a code by Abraham Lincoln. So when I run this program, this is what will be my output. A code by Abraham Lincoln is the first line. Second line, whatever you are, be a good one. The reason why, because we are using println. So after we print everything on the argument here, it will move to the next line. A code by Abraham Lincoln, move to the next line, then whatever you are, be a good one. Again, we may discuss this more detail, but for now, this is a Java program. It has at least one class, it has at least one method, and it has at least one or more statements. In Java, always our statements or expressions will be end with a semicolon. So we have semicolon to end each statement. So now we go a little bit detailed now. The Java program structure, we saw the program. So always we start, this is again application. So always we start with the main class. So public class, my program. So this means my Java file name will be my program.java when I save it. Then we open the parentheses, open and close. So this will be the class body. Comments can be placed anywhere. So comment can be placed almost anywhere in the program. So this is a comment. We have a 2 forward slash. This is called a single line comment. So everything I have here will be ignored by the compiler because it's a comment. It's not part of the Java program. So again, this is the basic structure. Now next, we need a method. So we have a method, and this is the main method. We have another comment again, just to explain what we have written in Java. Comments about the method. So here, public static void main string arguments. So here, anything I write that I want to execute in the main method will be between the 2 curly braces here. Again, to be between the 2 curly braces. So this is called the method header. This is called the class header. So this is the structure of a Java application, basic. Now from here, I can write any statement here inside the main method, and that will be the statement that will execute. So first, what is a comment? A comment always is included in a program. The purpose of it to explain the code, the Java code, or maybe to document the Java code. For example, when the Java program was written, who wrote it, etc. Now, they do not affect how a program works. So again, the compiler that will translate or interpret the source code in English to machine language, which will be 0101. If you see a comment, it will ignore it. Now we have 3 forms of comment. We said the first one, the double forward slash, is again single line comment. So everything is on one line. Multiple line comment, we start with a single line comment using only 1 forward slash, then asterisk. Then we end it with asterisk and also a forward slash. So yeah, I can have as many lines as I want. I start with 1 single forward slash and asterisk. No space between them. They are all together. Then you write any comment, any amount of line, then make sure you end it with asterisk and also a forward slash. Now we have what we call the Java doc command, which is Java document command. We start again with a forward slash, then 2 asterisks, then end it with a slash. And this also is a multiple line comments. So one thing we should know is that comment purpose is to explain the Java code or document the Java code, such as when it was created, the person who created it, etc. Always is ignored by the compiler. Now, most important thing now is the Java identifiers. So Java identifiers will be the name of all the possible Java elements, such as the variable, the method name, the class name. And we have some rules that we follow when we are assigning name, and we will go through that. So here we say identifiers are the words in a program. So this can be the name of a class, variable, method, any words. And a Java identifier can be made of, this is the rule, it can be made of what? Only letters, that's characters. The characters can be uppercase or lowercase, that's fine. Also include digits from 0 to 9. And the only symbol we are going to use is the underscore character and also the $sign. So we cannot use, for example, a comma, a space. There's no space between the identifiers names. In computer system or programming, a space also is a character. 1 space is 1 character, 2 spaces, 2 characters. So this is how we name our Java elements or the identifiers. We cannot start with the digits. So always we can start with either the underscore character or the letters. It can be uppercase or lowercase or the $sign, but we cannot start with a digit. And one thing we should know also is that Java is a case sensitive. So which means, for example, here we have 2 words. They are the same, total, total. But the first one start with the uppercase, the second one start with the lowercase. So this make the two words different. So that's what we mean by case sensitive. Java is a case sensitive. Uppercase letter and lowercase letter, the same letter, but they are not, their meaning is not the same. They are not the same. And also we have by convention, programmers can use different cases, style, it's up to you. So for example, I can name a Lincoln, start with uppercase and the rest lowercase. Or I can just use Lincoln, everything uppercase, etc. It's up to you. But normally when we declare variable and the variable is a constant variable, we use again uppercases. This is convention. This is not a rule. It's just a common practice. So sometimes also the programmer can choose the identifier, such as linking. We saw our linking. But sometimes the identifier, for example, here we have a method named println. It's already in the system, built in. It's a Java library file, or we use the term package. It's in a package. So we can name our own identifiers, or we can use the built-in identifiers, the class name. System is a class name. So the identifiers that is built in the package, we call those as a reserved word. I cannot use it for anything. So I cannot declare variable and name it println, because println is understood by Java as a method to print items on the screen. So this is an example of different types of reserved words. We can see public, return, short, implement. All these words means something to Java. So we can't use these names for any other. For example, I cannot create a class and name the class switch. So again, we cannot name any identifier using the Java reserved words. All these words mean something to Java. Now this is a quick check. Which of the following are valid Java identifiers? Remember we said Java identifiers, that is the name of Java elements, can be upper or lowercase letters. We can have digit in. We can also have an underscore character, and we can also have a $sign. And remember, we cannot start with a digit. So I will say, okay, the first one, and also we can use the reserved words. So the first is correct. Grade, I can name a grade. Quiz grade, this is also correct. Network connection, that's correct. Frame 2, that means the requirement is correct. So we can name identifiers, but we can see the next one start with a digit 3. This is incorrect. So this is incorrect because it starts with digit. The second one is correct. We can use uppercase or lowercase. The third one also is correct. We can use underscore between. The only thing we can't use a space. Student, this is wrong. Why? Because we are using the pound sign. The only symbol that we can use in Java is either underscore or $sign. Here we have a chefs and 1 and 2. This is this is N symbol %. So this is also incorrect. We can use, if it's a $sign, it should be correct. $sign or underscore. So the only two symbols we can use in Java identifiers is either underscore character or $sign. So this will be wrong. Chefs 1 and 2. We can't use the N symbol. We can't use the pound symbol also, so that's also wrong. So let's see the answer. We can see the invalid because we start with a digit. Invalid because we are using the pound or sharp character. And N character also, that's incorrect. The only character we can use again is the $sign and the underscore. So what is white space? We mentioned before, if I'm writing a statement and I press the space bar or enter key, I'm going to have a space, or the whole line as a space if I press enter key. These are called the white space in Java. Java compiler will ignore it. So it doesn't matter how it is. And we will see an example. So for example, here they say extra white space is ignored. If I have two words, let's say William James, if the space between is 1 or 2 or 3, it doesn't matter. Java will still print William James or whatever I want to do with it. There's no error. So this is we'll see examples soon. So the program development, we have techniques in developing program, but in this course, most of the program we are going to write is very small, so we don't need to follow the steps. But for example, if you are going to write a large and complex program, we have to follow some different techniques, which normally covered in software engineering class. For example, we can use something we call the waterfall model, or extreme program, or Scrum, or Agile. These are all different techniques of using to develop a computer. In this class here, the method they are going to teach us is almost like the waterfall method, because that's the classical method, almost the beginning of software engineering concept. So if I'm going to write a program or develop a program, it's not good straight ahead start to write the code. No, we have to take our time to understand the problem. Understanding the program is we're going to get what should be the input of the program, what should be the output. So we have to get the system requirements. The requirement, we have two types. The functional requirement means what the system is going to do. We analyze that. And also non-functional requirement is the quality of the system. We want the system to be user-friendly, to run very fast, or to be more secured. These are all again quality. So here we come up with the requirement analysis, what the system will do, the input, the output. Then we'll move to the next step, which will be the design phase. Here we can use any design tool to design the algorithm. It can be in English, it can be any word, any language you feel, or it can be a diagram. So example, we use something called a pseudocode. Pseudocode means I'm writing the code in English or any language, it's not Java. Just writing the steps, algorithm. Algorithm means solving a problem and following the steps in sequential order, in order. So I have to do the first thing first, second thing second, to solve the problem. So if we design finish, next, which will be the third phase, we move to the implementation. This is where we are going to write the code based on the design features. And then the fourth step will be testing. We have to test the code if there's any error, bugs, etc. If there is, we fix it, we test again. If everything is fine, then we can put the program in operation. In the process also, we have to find a way to maintain the maintenance of the program. So this is a step-by-step method, which normally we call the waterfall model. So programming language, each type of CPU executes only one particular machine language. This is very important. Actually, this is what the advantage of Java. Now, if I write a program, let's say in C++, it may run in one computer system. It may not run in another computer system because of the CPU language. So a program must be translated into a machine language before it can be executed by the CPU. A compiler is used, as we mentioned earlier. A compiler is used, again, it's a software tool which translates the source code, like Java code almost in English, into a specific target language, a target machine language that's understood by a particular machine system. We say sometimes that target language is the machine language for a particular CPU type. This is, for example, in C++ and some other programming, but Java is so different. That's why we say Java is a neutral platform. You can run Java program in any computer architecture, any CPU type. The reason is that after you compile the program finish, we are going to have a bytecode. Then this bytecode will be run on a special software, or I would say executor called a Java Virtual Machine, JVM. Now, if any program or any computer architecture have this Java Virtual Machine, it should be able to run the Java program. So that's why in the earlier stages of Java program, in the late 90s, Java program is mostly used to develop or create web applications, because in the internet and web, there are so many different platforms of computers connected together. So Java translation, you write the Java source code, then you use the compiler to compile the Java source code to a special representation called the bytecode. Normally, if you have the JDK, which is the Java Development Kit in your program, you can go to the DOS or command-driven phase. You type Java C, that's Java compiler, then you run it. Then next you type Java, and Java will be the executor to execute the program. Nowadays, we have so many. Actually, the couple of slides, we may go through some of the IDE, which is the Integrated Development Environment. The reason why we call it Integrated Development Environment, because we have a software that it has the text editor, so I can write the source code there. In the same software, I can compile it. In the same software, I can run it. So everything is in one phase, and it's a GUI instead of using the command-driven interface to write the code Java C and Java with the program name. So this is how it works. We have the Java source code. We use the Java compiler. We compile it. We get the Java bytecode. Java bytecode, we go to the Java virtual machine to execute it. So any program or any computer architecture, any software that have JVM in the computer system should be able to run Java. So development environment, we have so many of them. The most common one, which I'm going to use in this class, will be the Eclipse or JGraphs. I have both of them. NetBeans is also okay. BrewJ is okay. But Java development kit, here you have to use the command-driven interface. You can also use the command-driven interface. Then you type the Java C, Java to run it. Now, when we download the Eclipse, we also need to download the JDK with it. And the Eclipse is like IDE. So it has that editor, the compiler, the execution. So next, we should know what is a syntax and what is a semantics. In syntax, it's normally the grammatical rule of the program, Java program. So here we say that syntax rules of a language define how we can put together the symbols, the reserved words, and also the identifiers to make a valid program. So we have rules, and the very simple rule, as I said earlier, when I write a Java statement, I have to end it with a semicolon. When I create a Java method, I have to make sure I have an open and close parenthesis, so all the statements will be inside the method. And these are such a very simple rules we have to follow. But the semantics of a program statement define what that statement means. So semantics is the meaning of the, so now, let's say I wrote a Java program, we saw the linking.java. When I compile it and I have an error, that error will be a syntax error. So syntax error can be identified during the compiling phase. Maybe I misplaced the semicolon, I didn't include the semicolon, or I declared class, but I didn't close it with a curly brace, etc. So those are syntax error, grammatical error. Semantic error, I would say the meaning, which normally we use the term logic errors, is that, for example, I want to write a program to find the sum of two numbers, but instead of writing the sum of two numbers, I write the product of two numbers. So the syntax is okay. I compile it, it runs fine. And when I run it also, it runs good. But the output is wrong. So that's the meaning, the output is wrong. So it's very difficult to identify those errors. Syntax error is easy because you compile, it didn't compile. it will tell you the error. But logic error, it doesn't tell you. You have to look at the output and see if that's the output you are looking for. So those are the errors we discussed. We have 3 types of errors. The compiler will find a syntax error, which is the grammatical error, and other basic problems, let's say compile time errors. They say if a compile time errors exist, an executable version of the program is not created. So this is why it's easy for us to see the syntax error. Also, a problem can occur during the program execution, such as trying to divide by 0. This is called a runtime error, which means the syntax was okay. So when I compile, there's no problem. But when I run it, I have a problem because I'm trying to divide a value by 0, which is not correct. It's an error. So it's a runtime error. And then this is what I mentioned about. I wrote a program. Instead of a product of 2 numbers, I wrote a sum of 2 numbers. So these errors is called logical errors. You get results, everything worked fine, but the answer is not what you are expecting. So a program may run but produce incorrect result, perhaps using an incorrect formula. So this fault is not from the program, but rather from the individual who designed the program. We didn't use the correct formula for the calculations. So those are the 3 errors. Syntax error can be recognized by the compiler. Then we also have the runtime errors, which will give you a wrong output. Sometimes the program will even terminate, is to stop abnormally, which means it won't give you a full result. But it will compile good. Then during the running phase, then it may stop. We may discuss something like exception handling, how we can prevent those abnormally terminations. Then logical errors, everything will work fine. Your program run, you get a nice result, but you have to be sure. That's why in software field, in real world, we have a software testers. Actually, that's one of the entry job in software engineers. We have to keep using different types of input to test it and make sure we are getting the right output. So we have to take logical error, we have to be careful of it. So this is a basic program development phase with Java. We mentioned this earlier. So beginning, I'm going to write my source code. So I'll edit it, then I'll save the program. When I get my source file ready, I'll compile it. If there's error, I'll go back to the source code and then I have to fix it, which means I have a syntax error. In the compiling phase, as we said, only the syntax error occurs. And if nothing, then we run it. When we execute it, we get our result. If the result is error, then we still have to go back to the diction, the source code to go, and maybe the formula is wrong, something is wrong. So those are, again, the basic program development phase. So write your source code, compile it. If there's no error, you execute it. Then look at your result. If result is good, you finish. Result is not good, then go and modify your source code. That's where everything, okay. So I'm going to end here and we finish with Unit 1, Lecture Part 2. In our next video, we're going to start with the Unit 2, which will go detail about Java elements, variables, expressions, etc. So again, thank you. Bye.